Hi guys, morning. Um, okay, hope you're well. And another week. Now, just before we start, I'm going to give you a bit of information about the end of year, the exams after half term. I think you know about this anyway. Basically, you're going to have three exams, two pure and one applied paper. That'll be made clear nearer the time. It'll all be through Dr. Frost, and it's all on the A level content. Okay, so it's all on the book one and book two, and the applied book one and the applied book two. Okay, that's all the content. Next lesson, on Thursday and Friday, we're going to do some revision anyway through Zoom, so you'll be able to ask questions just to make sure that you know what you're doing, and I'll show you the best places to revise as well from there. Okay, right. So straight into the lesson, and we're going to start with a starter. This is all A2 material. Okay, so good revision. And I'm going to give you, this is a bit longer here, so I'm going to give, before we start going to complex numbers, we're going to spend a bit of time on this. I think 10 minutes is reasonable here, at least. So if you need a bit longer, do pause the video and do it properly, please. Okay, now we've got 10 minutes. You go. Okay, that's about time, guys. So if we scroll down to the answers here, do check what you got. Now the first one, you have to get it in the form R, R sine x plus alpha. R is the square root of 3 squared plus 2 squared, which is root 13, and then you get alpha by rearranging to get tan alpha equals something. Maximum to the power of 4, well, the maximum of that will be R. So the maximum of this is going to be root 13. The max of this is equal to root 13. So root 13 to the power of 4 is 169. And where that occurs, well, you just set that equal to 169. Solve it like an equation, and you should get those two. Okay. Any issues on these, please make a note of them. And then in the Zoom session on Thursday, we can run through. Okay, show that hx is that. Well, you just put fx into that. So 2x plus ln 2. Okay, and then you rearrange that equation, and you'll find that it does give you 4e to the 4x. Range, well, the range of that, if you were to sketch that graph out, it will look like that. It will go through 4, but it will be bigger than or equal to 0. And then the gradient of hx, you're differentiating hx. So h dash x, if you differentiate that, it's going to be 16e to the 4x, and then you substitute 4 in there. You substitute that equal to 3. Find the value of x where the gradient is 3. Yeah, so you set that equal to 3 and you solve that. Finally, last one, factorise the top one. Cross cancel, and then you're going to use this because you need to minus the lns from both sides. Minus ln both sides there, and then that's log laws, so you can then make that ln 2x is 9. And then you can do e to the both sides, and then you can go from there. So there's a few hints there for that question. Take your time to understand those and note any that you want me to have a look at next lesson. Okay. Right, moving on to the lesson now. We're carrying on with complex numbers and the loci of complex numbers. But before, we're just going to do a bit of a recap of what we've learned so far. So last lesson we looked at a circle. Now Cartesian from A level, we know that the equation of a circle looks like this. Okay, where A and B is the centre, AB be the centre there, and the radius would be R there. Yeah, okay, and we've seen that before. And in the complex mode, all we did is we looked at it in terms of vectors. So hopefully now you're seeing that the complex mode or area is really looking at vectors. And if we were to use the same thing, call that vector Z and that vector Z1, Well, r is quite simply z minus, if we call r an actual vector centre, it's going to be z minus z1. Okay, and for an equation of a circle, well, it's the magnitude of that vector z minus z1 is this vector here. So the radius is quite simply that vector, the magnitude of it. Okay, and we looked at that. So this is just a different way of writing the equation of a circle in vector form, really. Not even, doesn't have massively, you don't have to massively relate it to complex numbers, but you just look at it in vector form. Complex numbers are a good way of demonstrating that. Now today we're going to look at the locus, this equal distance from 2 points. Okay, so what's the equation of a line that would be equal distance from 2 points? Equation of line. Okay, now if I just draw out an Argand diagram, or just an axis really, let's start thinking of it as just an axis. And I'll put 2 points on here. Let's call that point A, that point B. Now, what's the equation of the line that will be equal distance from those 2 points? Well, the equation, any point that's equal distance is going to be along this line here. All of these points are equal distance from A and from B. So the equation of the line would be this. In reality, that equation of the line is the perpendicular bisector of AB. Okay, so how you would do that, you'd work out gradient of A to B, or the line that goes through AB, and then you would do the negative reciprocal, so that then perpendicular gradient, and then you know it passes through the midpoint. Passes through the midpoint AB, and from that information you'll get an equation in the form y equals mx plus c. We'll look at a specific example in a minute. Okay, that would just be in Cartesian, and we've done that before, no problems at all. Now if we go back into the imaginary domain, we're in the imaginary plane here, using this as an Argand diagram rather than a set of axes, any point along here could be described as vector z. That's standard, so we could call that vector z, or complex number z. Doesn't make, it means the same thing. Okay. Now by definition, if it's equal distance from 2 points, this vector here, let's call that one z1, and z2, well they will have the same distance, won't they? And if we call this point C, so we know using vectors, so an alternative equation using vectors or complex numbers, okay, you know that the distance A to C is equal to the distance B to C. And that is exactly our definition of equal distance from 2 points, okay? Now A to C, well how do I get from A to C using the vectors? I'm just going to redraw this slightly. I'm just going to call that vector is A to C, and this vector is B to C, apologies. But that vector there is Z2, and that vector there to B is Z1, okay? Move that Z closer. Okay. Now the vector, how do I get from A to C? Well, that is minus Z2 plus Z, or Z minus Z2. Okay, vector. And B to C is going to be Z, well, minus Z1 plus Z. Z minus Z1. And that there is the general formula for the equation equal distance between 2 points, okay? where Z2 and Z1 are the points, where Z1, 2 are points. Although we've described them as vectors, it's really the same thing. Okay. Right, let's look at an example. So, e.g., and this is the same example from the book. You can use this as a practice. So, Z minus 3 equals Z I. Okay. It is given that that magnitude Z minus 3 is equal to the magnitude of Z plus I. Sketch the locus of points. The locus of points Z. Now, when you've got an equation of a line, y equals 3x plus 5, or any line, all that you're doing there is putting in a locus of points. You're plotting a locus of points, or in other words, you're plotting unlimited points, infinite number of points which create a line. That's all this is saying. This is really just saying sketch that line, okay? And find the Cartesian. And find the Cartesian equation. Okay, step 1 to answer this, that's the question. Step 1 to answer it, we need to get into correct form. At the moment, we've got a plus there on the right hand side. They both must be negative. So I must make this Z minus 3, Z minus I. Okay, I must write it in that form, similarly to when we did the circles. It's got to be in the correct form. Now, if I've got it in that form, I now know that the 2 points of interest, so the point of interest here is 3 plus 0i, okay, and the point of interest here is 0 minus I, okay. In reality, this is sort of like a coordinate 3, 0. This is sort of like a coordinate 0 minus 1. There. Yeah. They're the 2 points that then the line is then equal distance from those 2 points. So let's plot those 2 points in. 3, 0. And here, minus 1. Sorry, 0 minus 1. Okay, now, by definition, this line is the line that's equal distance from both of these points. So it's going to be that perpendicular line there. Okay, that is the this is Z minus equals plus I. If you were to plot that on an Argand diagram, that is the line you would find. Okay. Now find the Cartesian. That's part B of this question. Well, this is how I have to go back to sort of straight lines now. So I use this coordinate and this coordinate. I go from there. So let's find the midpoint first. Midpoint, which is going to be 3 plus 0, 2. So half, that's the midpoint. Let's get the gradient A to B. I call that A, that B. Gradient AB is going to be change in Y, so 0 over 3. 1/3. Therefore, gradient of perpendicular, negative 3. So I know it's going to be y equals negative 3 plus c. And I know it passes through the midpoint. So I sub in midpoint. And I get minus a half C. A little bit of tip here, if I times everything by 2, just makes it easy for myself. Minus 1 is 9 C. I'm going to get 8 C equals 4. So my answer is y equals negative 3x 4. That's going to be my Cartesian. So in complex mode, it was this. Z minus 3 equals Z plus I. That means exactly the same thing as y equals minus 3x plus 4. Okay. Now the final part C, so part C of the question is find the minimum value of modulus z. Okay, find the minimum value of modulus z. Now that is the shortest distance. This basically means the shortest distance from the origin to the line. Okay, because it's the smallest value of z, the vector z, it's got to be the shortest distance from the origin to the line. Now to do that, I'm going to go back to my sketch. The shortest distance from the origin to the line, well, that is this, where that is 90 degrees, isn't it? Okay, that's the distance I'm trying to work out, x for sure. Okay, and I've got to think about how I might do that. Right, what I'm going to do is I'm going to call this line, let's say CD. Okay, I'm trying to work out the length of the line CD. CD is what I'm trying to work out. And you might want to pause the video, have a go. How do I work out the equation of that line? Or the length of the line? I think the first thing we need to do is work out the equation of CD. So equation of CD. Now, I know it has a gradient of a third because it's the same as the gradient of AB. So it's y equals third x plus c. I know it passes through 0, 0. Got to pass through the origin. So the equation of that line will just be y equals third x. Okay. Now I need to know the points of where they cross. So the coordinate of where it crosses at D. So it crosses at D, and in order to get that coordinate, it's where I'm going to set them equal to each other. I'm going to do a third x equals minus 3x plus 4. Let's work this out. Times everything by 3. X equals minus 9. 12. So 10x 12. Okay, so I know my x coordinate is 6/5, and my y coordinate will be a third of that, which is 6/15. Okay. Now I've got the coordinates. Now I can create a right angled triangle because I know that it goes from 0, 0. That was C. That's D. I know my y coordinate is 6/15, so my x coordinate is 6/5. So my equation, or this is modulus z, that's what I'm trying to work out. It's going to equal the square root of which is equal to, if I get my calculator up, (2√10/5), and that would be my answer. I'm a little bit worried that might not be it's a bit of a awkward answer, so that may not be correct. If I've made an error earlier on, guys, and you've spotted it, definite prize available. Okay, but I think the answer is 2√10/5, and that is how you answer those questions. So just a different way of writing a straight line, and there you go. We're going to do some questions on that now. Okay, so it's carrying on with exercise 2E. Exercise 2E. What I want you to do is question 6, right hand side column, and then question 7 and question 8. Okay, that's it for today, guys. Question 6, right hand side column, and this is all on page 34, 35. Okay. Right, next lesson is going to be a Zoom call for a bit of revision. We've nearly finished this chapter anyway, but yeah, so I'll see you then, guys, and any issues I'll be on the email, so just let me know. Thanks a lot.